is metadata? For any of you who do not know what metadata is or who are new to metadata, these are kind of indexing systems which label a document so that it can be identified. You might have noticed in your Google search or Bing search that you use certain words to search and these are thrown up as keywords. Or when you are probably creating a digitalized document, you provide certain keywords. So these keywords are a way of integrating these documents with the global system. We are trying to tell the world that this document deals with this keyword. For example, if I am uploading a document on Java J2EE or let's say patterns, design patterns, I will include design patterns, Java, J2EE in my keywords. So whenever somebody searches for design patterns, my document is caught and thrown up in their search. So indexing forms a major part in making your document available to a learner. What metadata does is it commonalizes or makes a common ground or platform for marking a document. So we need to bring about a support for global indexing. This indexing could also be for storage within the organization or archiving. It could be used in a library system or it could be used in a local intranet in a company. But all these documents should use the same metadata. Why? Because what is available in a global library can tomorrow become necessary for a company to access it. So if they speak the same language, the same indexing language called the metadata, then it will be easier to collaborate. Now this metadata should also support knowledge search. It should not only throw up your document in any common search, but it should also enable the related documents to this particular document should also be caught in the search. For example, if somebody is looking for same design patterns, Java, J2EE, they should also be given some more recommendations. Okay, so you are looking for design patterns, you might also be interested in learning about factory model, or you might also be interested about learning about web services. So these are related subjects to J2EE and design patterns. So a document should not only contain keywords, it can also contain a field which says, okay, this document deals with not only design patterns, amongst which factory model is one such pattern, it also deals with web services. So if you are pulling up this document in a search, you might also want to read about web services, you might also want to read in depth about factory model, so on and so forth. So this is how your search is recommended. This is most appreciated when we are looking for directions in a map online, or we are looking for movies to go to. So if a particular movie is not available at a particular time in a particular theater, the search should enable that, okay, this movie is available at this particular slot in another theater which is nearby to your theater. That would be really appreciated by a lot of us when we are searching for a movie to watch. So this is what is brought about by a standardized metadata. It enables knowledge search and discovery. In fact, what I told you just now is a tip of an iceberg. It has a lot of in-depth knowledge, and we need to go very deep into this in order to really explore this and bring out its potential. Metadata is also required to support the retrieval of learning objects across multiple tools and multiple types of repository. All of them, if they speak the same language, they will bring up the same kind of material instead of just throwing documents at the learner haphazardly. So in order to globalize this indexing system, the organizations have come up with certain standard indexing systems. The two most prominent indexing systems used are the DCMI, Dublin Core Metadata Indexing System, and the IEEE Metadata Indexing System. Okay? So these two are actually interrelated also. They are not so different from each other, so that they can actually pick up documents which are using the other indexing system also. For example, if your document is using DCMI, a system that is based on IEEE metadata indexing system can actually pick up these documents in its search. This is very useful for search and knowledge discovery in libraries, global libraries, or we can use this to implement one big global library of digital documents. Next comes the way we package the content. The content packaging should allow courses to be portable from system to system. In a lot of cases, the company itself might actually change its system midway for various reasons, business reasons or system reasons or infrastructure reasons, and they need all their content to be portable to the new system. If we have a standardized content packaging, this is easily done. However, if we have a legacy content packaging or something very particular to our own company so that it is highly secure, this becomes a headache and a bottleneck. So a company has to decide, a company or an institution has to decide a proper balance between how secure its documents are and how globalized and collaborative the documents are. One of the commonly recommended packaging system is SCOM, Shareable Content Object Relative Model. Lots of people are using this, but there are other content packaging systems like the IMS, which has actually been implemented long back and which collaborates with SCOM compliant learning objects also, which means even if we have a few different kinds of packaging, they can all collaborate with each other. The uniform format range has to be uniform, standardized across all learning objects. We should start using standardized formats for different kinds of learning objects. When I say learning objects, I mean images could be learning object, a document with a text can be a learning object, a video could be a learning object, an audio piece could be a learning object, anything. So the recommended formats are use vector graphics or SVGs for images instead of compressed graphics like JPEGs and PNGs. Even if you have such images, you may want to try to convert them into vector graphics, or in case that is not possible, the next best option is PNGs. Again, audio recommended is MP3. If you have RAM or other audio formats, that's fine, but if you can convert them into MP3, and you get a lot of converters nowadays, the effort is actually trivial and the benefits are multifold. Similarly, MP4 is recommended for videos, but then AVI is more popular, as we all know. There are certain examples for this standardization. For example, IMS is a simple sequencing methodology. ADL's SCOM is again another popularly packaging model used across all platforms. We are actually looking at the standardization of learning objects, so that once we standardize the learning objects, we can then start building systems which will standardize the communication between these learning objects. So those of you who have joined in late, we are looking at standardization processes for teaching materials or learning objects. Now, the next thing we come in the sequence is the learner profiling. The learner profile information could include personal data, learning plan, session plan, performance history, etc., etc. All these also need to be standardized. A standard is being brought about by IEEE. Next comes learner registration, which allows the learner profile graph. It indicates learners' requirements and prerequisites. For example, somebody who has not taken Java 101 might need to take Java 101 before he can jump into a master's course on Java J2EE. So these are captured in a learner registration system. It also gives an idea of learner preferences. Let's say a learner wants to combine history with computer architecture. Why not? So these preferences can also be captured. And based on these preferences, the student is then recommended certain courses, recommended certain reading materials, etc. Again, IMS has brought about some enterprise specifications and schools interoperability framework, which again we need to go into detail, which cannot be done in this particular webinar. Then we come to content communication. The content to be launched according to the learner requirements has to be standardized so that the learner data to be communicated is actually stored in the systems before the course is launched. For example, if one student wants to take up A, B, C courses, his preference is already recorded in the system before the launch of the course. And student B can similarly have his own preferences. So these courses are tailor-made according to the student preferences. So the courses are no longer standardized. A student does not go to a course, but the course comes to the student. Also, the content type needs to be communicated to the systems before the content is ever scheduled, so that the system verifies that the content is actually standardized content and can be broadcast from the system. The system or content compatibility check has to be done by a system before a course is launched. Again, IMS, ADL, SCOM, CMI, these are all doing a great job in bringing about the teaching material standardization. Now we come to the functional architecture, and we